Hi guys, today we're going to be looking at Cambridge A-Level Further Mathematics, Paper 4-2, October-November 2021. It's a further probability and statistics paper. So we will start now. For the first question, we have 40 pine trees of equal size in country A, and we call it X. And we have 60 pine trees from country B, and they have the same equal size, and we call it Y. So the sum of x is 752, the sum of x squared is 14,320, sum of y is 1548, and the sum of y squared is 40,200. So find a 95% confidence interval between the mean number of pine trees in regions of the size in countries A and B. So this question is about confidence interval, and let's list out the formula first. So for confidence interval, we would have the difference between the mean of x and y plus minus our z value, which we will get it from the table later, times s squared x over nx plus s squared y over ny, and we square root this. Alright, so now we will need to find all this info. Alright, so first thing, let's find for the mean of x. So it will be the sum of x divided by the number, which is 40. And this would give us 18.8. As for the estimate of variance of x, we call it s squared. We have 1 over the number of x minus 1, which is 40 minus 1 equals to 39, times x, the sum of x squared, which is 14320, minus the square of the sum of x, which is 752 squared, over the number of x, which is 40. So this would give us 304 over 65. And now let's go to y. The mean of y would be 1548 divided by the number of y, which is 60. So this would give us 25.8. As for s squared y, we have 1 over 60 minus 1, which is 59, times sum of y squared, which is 40,200, minus the square of sum of y, which is 1548 squared, divided by number of y, which is 60. So for this, we would have 1308 over 295. So now we can plug all these figures into this formula. So we have 95% confidence level, confidence interval. So let's copy this formula down. So we have 18.8 minus 25.8 plus minus the z value. We will need to refer to the formula sheet. So for 95% confidence interval, we will need to look at P equals to 0.975 because for confidence interval, this thing would be 95%. But when we look at a Z value, we need to look at this whole thing here, right? So this whole thing would be 97.5%. So we need to look at P equals to 0.975, and we know that the Z value would be 1.960. So we have plus minus 1.960 times the square root of 304 divided by 65 over 40 plus 1308 over 295 over 60. So the first value would be this figure minus this figure here, and we would get negative 7.86. And for the second value, we would have this plus this, and we would get negative 6.14. And we square bracket them. And this would be the answer. Question 2. It is claimed that the height of a particular age group of boys follows a normal distribution with mean 125 cm and standard deviation of 12 cm. Observations for a randomly chosen group of 60 boys in this age group are summarized in the following table. The table also provides the expected frequencies corrected to 2 decimal places based on the normal distribution with mean 125 cm and standard deviation 12 cm. Alright, so this would be a chi-square test following a normal distribution. So the first step, we need to show how the expected frequency for 130 to 140 is obtained. So we need to show this figure basically. And how do we find for the expected frequency? It's the probability for 130 to 140 times the number of samples. So first we need to find the probability. Alright, for a normal distribution, we need to change it to a Z value, right? So how do we do that? The Z value would be the X value minus the mean, which is 125, divided by the standard deviation, which is 12. And same goes to 130. So we plug this into the calculator and we would get Z is less than 1.25, and this would be Z is less than 0.417, corrected to 3 decimal places. So now we would look at the formula booklet. We go to this normal distribution function table, and we find for Z equals to 1.25. So 1.25. So we go all the way here. So this probability would be 0.8944. So we first write 0.8944 minus, so now we have to find for 0.417. So when z is 0.417, we go from here. So we take 0.6591 plus 0.0025, and this would give us 0.6616. Alright, so the difference would be 0.2328, and we take this value to find the expected frequency, which is 0.2328 times 60, which is the number of samples, and we would get 13.968, which is roughly equal to 13.97. For part B, we need to carry out a goodness of fit test at 5% significance level to determine whether the claim is supported by the data. So this will be a chi-square test, and first step, we will need a null hypothesis and alternative hypothesis. So the null hypothesis would be the normal distribution with mean of 125 and variance of 12 square is a good fit to the data. And the alternative hypothesis would be the opposite of it, which is the normal distribution with the mean of 125 and variance of 12 square is not a good fit to the data. Alright, so going to the second step, we need to make a table. So the first column would be the height in XCM. The second column would be our observed frequency, we call it O. Third column would be the expected frequency, we call it E. And the last column would be our chi-square. Alright, so looking back at the original data, we can see that the expected frequency for x less than 100 is 1.12, which is less than 5. So when it is less than 5, we need to combine the two columns together. So we need to take this plus this to make this a group. Alright, and the others are more than 5, so they are fine. So we just need to combine these two columns. Alright, when we combine these two, the height would be x is less than 110. So the first row would be x is less than 110. The second row would be x in between 110 and 120, so on and so forth. Alright? So after copying all the categories, we need the last row being the total. So now we can just copy the observed frequency and the expected frequency, But keep in mind that we already combined these two, so the observed frequency would be 0 plus 3, and the expected frequency would be 1.12 plus 5.22. So this would be 3, and this would be 6.34. So this would be 15, this is 13.97, this is 23, this is 19.38, this would be 11, and 13.97, this would be 8, and 6.34. And now for chi-square, we need to calculate all these values. So the formula for chi-square would be the square of observed frequency minus the expected frequency divided by the expected frequency. So we just calculate for this row, and this would give us 1.7595. And for the second row, we get 0.0759. Third row would be 0.6761. Fourth row, 0.6314. Fifth row, 0.4346. Okay, now we have to find for the total. So these two, the total must be 60. So if you find that the total here and here is not 60, that means you might have done some mistake and you need to check on it, alright? Because the total number of sample is 60, so the total frequency must be 60. As for the chi-square, we add all this together and we would get 3.5777. So for the third step, we know that the test statistics would be chi-square equals to 3.58, corrected to 3 significant figure. This figure is from this sum of chi-square over here. As for the critical value, we know that our p-value would be 0.95 because we are testing it at 5% significance level. So p would be 1 minus 0.05, and the degree of freedom would be the number of rows minus 1. So we have 1, 2, 3, 4, 5. So 5 minus 1 would be 4. And for the chi-square critical value, we will need to look at the formula booklet. So we look at V equals to 4 and P equals to 0.95. So this would give us 9.488. Alright, so for the fourth step, we need to compare the test statistics and the critical value. So we know that the test statistics, 3.58, is less than the critical value, which is 9.488. And in this case, we will need to accept our null hypothesis. So for the chi-square test, when our test statistics is smaller than the critical value, we would need to accept our null hypothesis. So for the fifth step is our conclusion. So for the conclusion, we can write at 5% significance level, there is sufficient evidence that the normal distribution with mean of 125 and standard deviation of 12 square is a good fit to the data. So we're done for this question. Third question. The continuous random variable x has probability density function f given by fx equals to a plus 1/5 x when x is in between 0 and 1, and fx equals to 2a minus 1/5 x when x is in between 1 and 2. A is a constant, so now we need to find the value of a. So we know that the total probability is always equal to 1. So what we have to do is we integrate these two equations, and the sum of them will be equal to 1. So we integrate a plus 1/5 x from 0 to 1 plus the integration of 2a minus 1/5 x from 1 to 2. And the addition of it is 1. So now we have ax plus 1/10 of x squared from 0 to 1 plus 2ax minus 1/10 of x squared from 1 to 2. And this would be equal to 1. So now we sub these values into x and we get a plus 1/10 plus 4a minus 4/10 minus 2a minus 1/10 equal to 1. So now we simplify it and we would get 3a equal to 6/5, and a would be 2/5. For part B, we need to find the expectation of x squared. So what we do is we integrate x squared times fx. So this means that we have the integration of 2/5 x squared plus 1/5 x cubed from 0 to 1 plus the integration of 4/5 x squared minus 1/5 x cubed from 1 to 2. So now we have 2/15 x cubed plus 1/20 x to the 4 from 0 to 1 plus 4/15 x cubed minus 1/20 x to the 4, 1 to 2. So now we sub the values into x and we would get 2 over 15 plus 1 over 20 plus 4 over 15 times 8 minus 2 to the 4 over 20 minus 4 over 15 minus 1 over 20. So this would give us 13 over 10. Part C. Find the cumulative distribution function of x. So we call this CDF, and we have a few steps. So for the first step, we have x less than 0. So for x less than 0, fx would be equal to 0. Second step, x is in between 0 and 1. So for this one, our fx would be f0 plus the integration of 2 over 5 plus 1 over 5x from 0 to 1. Sorry, 0 to x. So f0 would be 0 because when x is less than 0, fx is equal to 0. So f0 is 0 plus 2 over 5x plus 1 over 10x squared from 0 to x. And this would give us 2 over 5x plus 1 over 10x squared. So for the third step, when x is in between 1 and 2, we have fx equal to f1 plus the integration of 4 over 5 minus 1 over 5x from 1 to x. So f1 would be subbing 1 equal to x in this. So we have 2 over 5 plus 1 over 10 for f1. And for the integration, we have 4 over 5x minus 1 over 10x squared from 1 to x. So now we have 1 over 2 plus 4 over 5x minus 1 over 10x squared minus 4 over 5 minus 1 over 10. So we would get negative 1 over 5 plus 4 over 5x minus 1 over 10x squared. So now the fourth step, for x is more than 2, our fx would be 1. So you can see that according to the PDF, the probability density function, when x is in between 0 and 1, and when x is in between 1 and 2, there is a certain function, and anything otherwise, we have a 0. That means anything before this range let's say x is less than 0, there is no graph. So the probability would be a 0, and that's why the first step is when x is less than 0, fx equals 0. And for the second step, when x is in between 0 and 1, we have this function over here. So to find the CDF, we integrate this function. Alright, we integrate this function over here from 0 to x. And remember to add back f0, 0 being this number over here. For the third step, we integrate this function over here when x is in between 1 and 2. So for x in between 1 and 2, we integrate this from 1 to x. So from this number to x. And remember to add back f1. So after this range, we have x more than 2. And everything after this, we have a probability of 1. So now we can write into the proper, I would say a proper way of presenting our answer. So we have 0 when x is less than 0, and 2 over 5x plus 1 over 10x squared when x is in between 0 and 1, and negative 1 over 5 plus 4 over 5x minus 1 over 10 x squared when x is in between 1 and 2. So fx will be 1 when x is larger than 2. Question number 4. Applicants for a particular college take a written test when they attend for interview. There are two different written tests, A and B. Each applicant takes one or the other. The interviewer wants to determine the medians of the distribution of marks obtained in the two tests are equal. The marks obtained by a random sample of 8 applicants who took test A, so this would be the number for A, and a random sample of 8 applicants who took test B, so this is the number of applicants for B. Carry out a Wilcoxon rank sum test at 5% significance level to determine whether there is a difference in the population median marks obtained in the two tests. So this is a Wilcoxon rank sum test. And okay, for the first step, we have our null hypothesis and our alternative hypothesis. So the null hypothesis would be both medians are equal. And the alternative hypothesis would be both medians are not equal to each other. Alright. Second step, we can start finding for the critical value. So we know that we need to know what is the value for m and n. M being the smaller sample size, but in this case, since they are both the same, so we know that m equals to n equals to 8. And it's a two-tailed test, right? Because this is unequal instead of bigger or smaller. So now we refer to the formula booklet. Let's find for rank sum test. Yes. So for critical values of W, we have m equals to n equals to 8, which means m equals to 8 and n equals to 8 as well. It's a two-tilt test, and we know that the significance level is 0.05. So we know that it's this one. So this should be the critical value, 49. So for critical value, W equals to 49. So for the third step, we have our test statistics. So for Wilcoxon rank sum test, we would need to rank all the data. So we have 8 samples for each group. So we need 8 rows, 1, 2, 3, 4, 5, 6, 7, 8. Another row for total. Alright. So this would be the test A, this would be for test B, and this is the ranking. So now we can copy all these values, into this table here. Alright, so for test A we have 46, 32, 29, 12, 33, 18, 25, and 40. For test B, we have 36, 28, 49, 37, 48, 35, 41, and 31. So now we need to start ranking all the test scores. And when we rank, we don't just rank for test A alone and test B alone. We actually mix both of the tests together and rank them together. So we know that the lowest score would be 12, so this is rank 1. Second would be 18, third is 25, fourth would be 28, fifth would be 29, sixth is 31, 7 would be 32, 8 would be 33, 9 would be 35, 10 would be 36, 11 is 37, 12 is 40, 13 is 41, 14 is 46, 15 is 48, and lastly 16 is 49. So now we need to sum up all these rankings and write it here. Alright, so the total ranking for test A would be 52, and the total ranking for test B would be 84. So now we know that the RM, according to the formula booklet, would be the sum of the ranks of the items in the sample size M. But since we know that in this case M equals to N equals to 8, so you can take either one of them. I prefer using test A, so my RM would be 52. And now we need to find for R prime M. So R prime M is given by this formula here. So we have 8 times 8 plus 8 plus 1 minus our Rm value, which is 52. And R prime M would be equals to 84. So if you use this value as Rm, 52 would be the R prime M. Alright? So our test statistics value would be the smaller between these two values. So obviously we have 52 as our smaller value. So for the fourth step, we compare the test statistics and the critical value. So the test statistics is 52 and the critical value is 49. And obviously 52 would be larger. So when the test statistics is larger than the critical value, we accept H naught. Alright, this is also written in the formula booklet. It says that the table gives the largest value of W, which will lead to rejection of the null hypothesis. That means anything that is smaller, any test statistics that is smaller than this, we can reject the null hypothesis. But since our test statistics is larger than 49, we accept our null hypothesis. Now for the fifth step, I'm running out of space, so I'll just squeeze them together. We would have our conclusion. So our conclusion, let me shift this up a bit. So for our conclusion, we can write at 5% significance level, there is insufficient evidence to conclude that there is a difference in the population median marks obtained in the two tests. For part B, the interviewer considers using the given information to carry out a paired sample t-test to determine whether there is a difference in the population means for the two tests. Give two reasons why it is not appropriate to use this test. So paired sample t-test requires the two population to be a paired sample, obviously. And from the question, we know that each applicant takes one or the other. So it's not that each applicant takes both tests and we see the difference. So this is obviously not a paired sample. So the first reason being tests A and B are not paired sample. Alright, the second reason, so we know that when we want to do a t-test, the probability distribution of the population has to be a normal distribution. And in this case, it doesn't specify that it is a normal distribution. So the second reason can be the population which the sample is drawn from has a known probability distribution. And that is why we are using non-parametric tests instead of the t-test. Question 5. The random variable x is such that the probability of x equal to r is kr squared for r equals to 1, 2, 3, and 4, where k is a constant. find the value of k. Let's draw a probability distribution table. So we have our x value being 1, 2, 3, and 4. And the probability when x is equal to all this is, for x equals to 1, the probability is k, x equals to 2 is 4k, x equals to 3 would be 9k, and x equals to 4 would be 16k. So the total probability is equal to 1. So k plus 4k plus 9k plus 16k equals to 1. And 30k equals to 1, so k would be 1 over 30. Part B. Find the probability generating function of x. So the probability generating function would be the sum of t to the power of x times the probability when x is equal to x. So this means that we just multiply this with t to the power of 1 plus this times t to the power of 2 plus this times t to the power of 3 plus this times t to the power of 4. So we have 1 over 30t plus 4 over 30 t squared plus 9 over 30 t cubed plus 16 over 30 t to the 4. Part C. The random variable y has probability generating function equals to 1 over 4 plus 1 over 2t plus 1 over 4t squared. The random variable z is the sum of x and y. Assuming that x and y are independent, find the probability generating function of z as a polynomial in T. So when z is equal to x plus y, the probability generating function of z would be the probability generating function of t times the probability generating function of y. So we have this thing over here times this thing over here. We can factorize the fraction out, maybe even the t, so it's not that complicated to multiply. Times 1 over 4 times 1 plus 2t plus t squared. So for the fraction, we have 1 over 120 times t times 1 plus 2 plus 4 times t plus 1 times 8 times 9, 1 plus 8 plus 9 times t squared plus 4 plus 18 plus 16 t cubed plus 9 plus 32 t to the 4 plus 16 t to the 5. So now we have 1 over 120t times 1 plus 6t plus 18t squared plus 38t cubed plus 41t to the 4 plus 16t to the 5. So they want a polynomial in t. So let's expand the bracket. So we have 1 over 120t plus 1 over 20t squared plus 3 over 20t cubed plus 19 over 60t to the 4 plus 41 over 120 t to the 5 plus 2 over 15 t to the 6. Part D. Given that Ez equals to 13 over 3, use GZT to find the variance of Z. So we know that the formula for variance would be G prime 1 plus G prime prime 1 minus the square of G prime 1. Alright, so now we need to find G prime 1 and G prime prime 1. So we have GZT equal to this thing over here. Let's just copy it down. So differentiate this, we have G prime t equal to 1 over 120 plus 1 over 10t plus 9 over 20t squared plus 19 over 15t cubed plus 41 over 24 t to the 4 plus 4 over 5 t to the 5. And G prime prime t would be the differentiation of G prime t. So we have 1 over 10 plus 9 over 10t plus 19 over 5t squared plus 41 over 6t cubed plus 4t to the 4. So now we know that G prime 1 equal to 13 over 3. How do we know that? Because the expected value of Z would be equal to G prime 1. So we know that G prime 1 equal to 13 over 3. So now G prime prime 1 is equal to 10 plus 9 over 10 plus 19 over 5 plus 41 over 6 plus 4. And this will give us 469 over 30. So now the variance, we have G prime 1, which is 13 over 3 plus G prime 1, which is 469 over 30 minus the square of G prime 1, which is 13 over 3 square. So our final answer would be 107 over 90. Question 6. A scientist is investigating the masses of a particular type of fish found in lakes A and B. He chooses a random sample of 10 fish of this type from lake A. So this would be the number, they call it X, so it's the number of sample for X. The scientist also chooses a random sample of 12 fish for this type from leg B, but it only has the summary of their masses y kg. So this would be the number of y. Test at 10% significance level whether the mean mass of fish of this type in leg A is greater than the mean mass of fish of this type in leg B. You should state any assumptions that you need to make for the test to be valid. So let's state the assumptions first, just in case we forgot later. So the first assumption for a t-test is the population from leg A, from legs A and B are normally distributed. And since the sample size is considered small, we have another assumption to make, which is the population from leg A and B have common population variance. Take note that it's not sample variance, alright? It's population variance. So now let's go to our t-test. So first step, we have the null hypothesis and alternative hypothesis. Null hypothesis would be the mean of A equal to the mean of B. And the alternative hypothesis would be the mean of A is larger than the mean of B, as stated in the question. So second step, we have our critical value. So we know that this is a one-tilt test and the significance level is 10%. So our p-value would be 0.9. And for the degree of freedom, V, we have the number of samples for A, which is 10, plus the number of samples for B, which is 12, minus 2. So this would be 20. So now we refer to the the formula booklet. So we have P equals to 0.9 and V equals to 20. Where is 20? Alright, 20 is here, 0.9 is here. So this would be our t value, which is 1.325. So our critical value would be t equals to 1.325. Going to the third step, we need to find for our test statistics, but before that we need our data. So we already have the sum of y and sum of y squared, but for x values we need to calculate ourselves. So we have the sum of x equal to 21.2 and the sum of x squared would be 47.92. So from this values we know that the mean of x would be 21.2 divided by 10, which is 2.12. And the mean of y, we know that it's 24.48 divided by 12. So we would get 2.04. So now we need to calculate the unbiased estimate for variance, which is s squared. And the formula for that is the sum of x squared minus the square of sum of x divided by the number of sample for x plus the sum of y squared minus the sum of y squared divided by the number of samples for y. So this whole thing would be divided by the number of samples for x plus the number of samples of y minus 2. So now we sub all the values in. We have 47.92 minus 21.2 squared over 10 plus 53.75 minus 24.48 squared over 12. This whole thing is divided by 10 plus 12 minus 2. So we would get 0.33934. This is the exact value that we got. So for our test statistics, we have the mean of x, which is 2.12, minus the mean of y, which is 2.04, divided by our s-square value, 0.33934, times 1 over the number of samples of x, which is 10, plus 1 over the number of samples of y, which is 12, and we square root this. So we would get 0.321, rounded to 3 SF. So the fourth step, we would compare the test statistics and our critical value. So let's draw the right side of the normal distribution graph, because it's a one-tilt test, right? So this would be 1.325, which is our critical value, and our test statistics would be somewhere over here, which is 0.321. And we know that this region is the acceptance region, and this would be a rejection region. And our test statistics falls under the acceptance region, so we would need to accept H0. So the last step, we would have our conclusion, which is at 10% significance level, there is insufficient evidence to conclude that the mean mass of fish in Lake A is greater than Lake B. And we're done with this paper.